So we're starting on the rational today. We're going to start with the basics, the graphs, the transformation. It's pretty the similar things that you have been doing so far with all the other graphs. The only thing is a little bit difference is this one. Since you are working on the rational, so there will be discontinuities. So horizontal asymptote, vertical asymptote play a big role on this one. So try to understand those topics and you will be pretty good. The starting is the most important one. Once you build up the foundation, moving forward is going to be very easy. Okay, these are the standard point that we always take to get a clean graph on this one. So it's 0, 1, 2, -1, -2. We're going to substitute all the values in the graph, in the function, sorry. So it's given 1 over x. So if you plug in 0 over here for x value, what do you get? 1 over 0 is going to be undefined. It's not 0. That's where everything builds up. This is the most important concept whenever we are dealing with the rational functions. So 1 over 0 is going to be undefined. Undefined means what? That graph is not going to have any value, so it's not going to go through that point at all. This is where the asymptote concept comes. What is an asymptote again? A line or a point, the graph will never cross or touch that line. So that's the asymptote. And we're going to talk about asymptote a lot. So 1, if you substitute 1 over here, what do you get? 1. If you substitute 2 over here, what do you get? 1/2 or 0.5. It's easier if I have a decimal value to plot it over here. That's why I'm just taking decimal. You can keep it as a fraction. That's okay. -1 is going to give me, -1 is going to give me -1, -2 is going to give me -0.5 or -1/2. Now the domain, let's draw the graph over here. Let's try to draw it. Let's plot the points over here. So I have 0 is undefined, so that's not going to touch it over here. 1, 1, so that's my first point. Then I have 2, 0.5. 2, 0.5 over here. If I plug in 3, can you check it what you get? What's the value for 1 over 3? 0.33. So it's becoming smaller. Can you connect it with it? So it's going to be 0.33. It's more smaller. If you keep moving, it's going to give you smaller points over here. But it will never cross that line. Now, if you make it bigger, let's see if I'm if I'm plugging in any point over here. So I want to get the points on this side. If I plug in 0.5 over here, or on this one, so 0.2. If I plug in any smaller fraction values on this one, think about it. If I plot x is 1/2, I'm plugging in it over here, and my function is given f of x is equal to 1 over x. I'm plugging in 1/2 in place of x. So how do I do that? 1 over 1/2. Correct? I'm plugging in 1/2 over here. So if I plug in this one, it's going to be keep, change, flip. 1 times 2 over 1, it's going to give me 2. So the smaller value you plug in, you are getting a big y value. So if I plug in 1/2, it's going to give me 2. If I plug in 1/3, it's going to give me 3. If I plug in 1/4, it's going to give me 4. So every time I'm plugging in any smaller value, it's going to give me a bigger y value. Similarly, on the other side also, -1, -1, that's my first point, -2, -0.5, and we're going to get more smaller points, and if you put smaller values, it's going to give you bigger points. That's going to be your graph. Any question up to this point? Great. Let's look at the domain now. Domain are what values? X value or Y value? X values. Okay, tell me, what will be the domain? What X values did we take? Negative infinity up to a 0, and then again from 0 up to infinity, because 0 is giving us undefined value. We cannot take that. So, is 0 included? Is it open or closed? It cannot be closed. If it is closed, I'm taking 0. That cannot work. So, I have to skip 0. So, negative infinity up to a 0, and then from 0 up to an infinity. Wait. And then the range. What is the range now? Y values. So what will be the range in this case? What are the values that we have? Negative infinity up to a 0. Again from 0 up to infinity, because these are all the Y values, so we are getting all of that one. Is the graph increasing? You are giving a bigger X value and you are getting bigger Y value? No. Every time, if the X value is getting bigger, you are getting smaller X values, not the bigger ones. So, it's never increasing. Decreasing, is it decreasing anywhere? It's always decreasing. For any X values, it's decreasing. So, starting from negative infinity up to 0, also from 0 to infinity, it's always decreasing. The bigger X value you plug in, the smaller Y value you get. X-intercept and Y-intercept. Do we have any X-intercept? None. Do we have any Y-intercept? None. Do we have any vertex? What is a vertex now?
The highest and the lowest one.
That's the maximum or the minimum. What is a vertex? Say it again. No, that's the end point. The vertex is the point where it's there you go. So where it changes the direction. It starts on one direction. So if it is going towards up, and then it changes going to the other direction. As we saw in the cubic function or cube root function, it's coming and then it's changing the direction going to other side. Okay. So do we have any vertex over here? It's coming, changing the direction, going to another one. It's none. Even if sometimes it's confusing. Maybe this is the vertex and it's changing the direction. It's technically not. Symmetric. Is it symmetric? Does it look symmetric if I fold it? Okay. So where is it symmetric? So the origin, y equal to x. It's a point symmetry. Roots. Do we have any roots? None, because it's never crossing the x-axis. How can I get a root? Now comes the asymptotes. Here, the asymptote, do we have any? What are the asymptotes? X equal to 0 and y equal to 0. Because the vertical asymptote is going to be y equal to 0 and the horizontal asymptote is, vertical asymptote is y equal to x equal to 0 and the horizontal asymptote is y equal to 0. Maximum. Do we have any maximum point? It going towards infinity, so there is none. Do we have any minimum value? Axis of symmetry. Is there a line? No, it's a point symmetry. It's an origin just according to the point. So, there is none. Let's draw the vertical and the horizontal asymptotes. Every time you will be expected to draw the asymptotes. And the asymptotes will be always a dotted line. All right. All right. Now we're going to talk about the most important thing that we're going to talk over here, the asymptotes. So the horizontal asymptote and the vertical asymptotes. Now, whenever we're talking about the horizontal asymptote, there are three different types, okay, that we're going to deal with. And we came up with a short form just to remember them. There are so many things, so we just came up with a short form so you can remember those. The first one is the BOBO. The way how we named them is that we just took all the first letters of the abbreviation and then we just made it. So the BOBO means bigger on the bottom. And it's going to be y equal to 0. So we just took the 0. It's not technically BOBO though. This is 0 and those are the letters. I'm going to explain it in a sec. Just try to understand what it means. It will be easier. And then the next one is bigger on the top. So bot n, which is going to be bigger on the top, there will be no asymptotes, no horizontal asymptote. We are only talking about the horizontal asymptote, not the vertical yet. And the last one is its DC. So it means exponents are the same. So in that case, we are going to divide the coefficients. That's how we named them. Let's see how it works. Bigger on the bottom means we're going to only look at the powers or the exponents on the top, okay? The degree of the exponents on the leading term, not the whole term. If you have a big term, we are just only look at the leading term, not anything else. So if you have the, say for an example, if I have x over x to the power 4, so over here, I'm just giving an example, x over x to the power 4. So who is the bigger one? X to the power 4. So the bottom is the bigger, so it means you don't need to calculate anything. The horizontal asymptote is going to be y equal to 0. So directly you can write it down. Okay? So bigger on the top means if I have x to the power 5 over x plus 2. So which one is the bigger? X to the power 5 is the bigger one, right? So in that case there will be no horizontal asymptote. So none. Now the its DC is that if both of them are same, the same coefficient. So I have 5x cubed over 2x cubed minus 1. I'm just giving an example. So is the coefficient, is the leading term has the exact same exponents? So if they have the exact same exponent, your horizontal asymptote is going to be y equal to 5 over 2. You're just going to take the coefficient of both of them. All right? Let's do some problems over here that's already given for us. Let's work on this one. Look at number 1. Okay, now tell me. Leading coefficients are what? X squared over x. So which one is it? The first one, second one, third one. BOBO, bot n, or its DC. Which one? The second one. Bigger on the top. So what does it mean? What will be my horizontal asymptote? None. Perfect. Let's look at the next one. Number 2. So here, I'm writing it separately just to see it easy. X over X. So which one is it? Bobo, bot N, or it's DC? Which one? It's DC because they have exactly the same thing. So what will be my horizontal asymptote? Y equals? 1 over 1. I need the coefficient. Whatever is the coefficient over here, I'm going to take that one. So 1 over 1. So it's going to be y equal to 1. Question? Confusion? We good? Give me a thumbs up. Perfect. Number 3. Over here you have to simplify the denominator. I cannot work with it if I have a factored form. So find the value for the denominator. F of x is going to be what? 2x over. You can distribute or you can put it in the box and then multiply it. Go ahead, do it by yourself. I'm giving you 30 seconds. Okay, now give me what do I have at the bottom? X squared minus 3x minus 10. So we're just going to take the leading coefficient. So I have 2x over x squared. Which one is this one? Bobo, bot N, or it's DC? Which one? Bobo, because on the bottom the denominator has the bigger power. So this is Bobo. What's the horizontal asymptote now? Huh? Y equals 0, not 0. Asymptote is a line, so it has to be y equal to 0. Any question on this one? You are going to see this using almost every single day, so you really have to get used to with it. Any question on this? Let's move on. All right, now comes the graph. Let's look at the graph. We're going to consider the transformation as well. Transformation rules are exactly the same. How you did it before. Nothing changes, so I didn't attach the transformation paper with this packet anymore. It's already too thick. Okay. Now let's look at this one. What is the transformation over here? What is the transformation? Do I have any? Huh? Left 2. Perfect. So all the vertical and the horizontal asymptote, whatever we have, we are shifting the entire graph on the left side to unit. Make sense? Yes. All right, perfect. Now, let's look at the domain range first. We are going to shift the horizontal asymptote. X is going to go on the left 2 units. So let's look at that one first. We're going to draw that one first. So the vert 2 over here. Now, we're going to talk about the other thing. Whenever you are trying to find the domain from anything, whatever you have on the denominator, you have to set that equal to 0. That's going to give you the domain. So I have x plus 2. I'm going to, for the domain, set x plus 2 is equal to 0. What's the x value now? X equal to negative 2. That's going to be your domain. Also, that's going to be your vertical asymptote. So I have x equal to negative 2. From negative infinity, it's going to be up to a negative 2. Union from negative 2 up to a infinity, sorry.
Well, Ms. Jan,
Yeah,
question.
sure.
For negative 2, it's, like, you made a bracket, right? So is it like open, will it be closed because it's touching the,
No, it will never touch the vertical asymptote. It's the vertical asymptote at -3. That's why I cannot keep it at close. You cannot take that point. It's going to give you undefined value. If you plug in -2 over here, 1 over -2 plus +2, it's going to be 1 over 0. 1 over 0 is undefined. So that's not possible. And the vertical asymptote is the exact same point. It's going to be x equal to -2. That's what you found already. So finding the vertical asymptote and finding the domain is very easy. Now we're going to look at the graph, and we're going to try to find the horizontal asymptote, also the range. For the horizontal asymptote, if you look at the function over here, what is this rule is going to be? Is it Bobo, bot n, or it's DC? Which one? Bobo, bigger on the bottom. So Bobo. If you have a Bobo, what's the horizontal asymptote? Y equal to 0. We don't need to calculate anything. Let's draw the graph. When I draw any graph, for me is the best way to do it if I make the table and do the transformation. If you want to do the graphing like you're just moving it, some people find it easier. Okay, since I'm going to the vertical asymptote is -2 and there is a transformation going to the left -2, I'm just going to transfer all the point to the left side -2 values. But for me, it's easy when I see it in the table, so I can just plot it, and that gives me the table, gives me the graph. There is no right or wrong way. As long as you are doing it correctly, I'm fine with it. So I'm going to make the table for my help. Let me take the original table. So it's 0, -1, -2, 1, 2. This is the original. 0 is going to give me undefined. I'm taking the table that we did at the very first page. The table that we did it for the original graph. 0 is undefined. -1 is -1. -2 is -0.5. +1 was +1. And +2 was +0.5. It's the new packet. Now we have going to the left. If you go to the left or right, it always goes with your x value. If I'm going to the left, I have to subtract 2 from the x value. That's going to give me the new table. All the y value stays the same. I just have to change the x values. So here it's undefined. Nothing changes on any of the y values. Everything stays the same. For the x values, the new values are going to be -4, -3, -2, -1, and 0. Let's plot it over here. I have -2 undefined, of course. That's the -2 undefined point. -3, -1. -4, -0.5. So that's going to be one of my graph. The other one on the other side, it's going to be -1, 1 and 0, 0.5. Perfect. That's my new graph. If you look at this one, the horizontal asymptote was x equal to 0, y equal to 0. So we are going to draw that also. What is the range? What's the range? Negative infinity up to 0, because that's your horizontal asymptote. You are going to go up to the horizontal asymptote and then 0 to infinity. Do number 2 and 3 by yourself. I'm giving you 6 minutes. I'm looking for domain, range, vertical asymptote, horizontal asymptote, and it has to be shown in the graph also. If it is an asymptote, left and horizontal and vertical asymptote, you have to put the dotted lines, and the graph has to be the solid line. Go ahead, get started on that one. I'm giving you 6 minutes. Okay. When I was looking at your work, many of you got confused with the horizontal asymptote. Okay. So even though this this function shows that, what is the rule for this one? It's Bobo, so it's going to be bigger on the bottom. But there is a transformation. You are going down 4 unit. So it cannot be y equal to 0. It happens if you don't have any up or down transformation. I should have mentioned it earlier. So since you are going down, that's going to give you the horizontal asymptote, which is y equal to negative 4. What's the vertical asymptote? What is the vertical asymptote? X equal to 0. Because you said this equal to 0. At the bottom, you have x only. There is no transformation. So that's going to be your vertical asymptote. Now the domain. The domain and the vertical asymptote is the same. What is the domain? Negative infinity up to 0 and 0 to positive infinity. What is the range? Range and the horizontal asymptote, they are the same thing. Negative infinity up to a negative 4 and negative 4 up to an infinity. Let's draw the asymptotes first. When I draw the graph, if there is an asymptote, the best policy is to draw the asymptotes first. It's going to make your life much easier. Let's draw the asymptotes first. So it's x equal to 0. That's my vertical asymptote. Let's draw that one. Don't forget it's a dotted line. And then it's y equal to negative 4. That's the horizontal asymptote. You're going down 4 unit. Since there is only one transformation, we can just look at it and draw the graph easily. But again, it's a better practice if you know how to do the transformation, so you can do that way. So here, I'm just going to take the table one more time. So 0 undefined. And we have negative 1, negative 2, positive 1, positive 2. This is 1, 0.5, negative 1, negative 0.5. We have the transformation in the going down 4 unit. What should I do with it if I'm putting it in the table? What do I do? Minus 4 with the x or y? Y. So negative 4 with the y values. Let's make the new table over here. That's going to be for the transform table. So let's make it again. X value doesn't change at all. 0, negative 1, negative 2, 1 and 2. That stays the same. The new y values are going to be over here. You're subtracting negative 4 from this one. So this over here, it's going to be negative 4.5. This one is going to be negative 5. For here, since it's undefined value over here, so it's going to be negative 4 at this place. On this one, it's going to be negative 3. On this one, it's going to be negative 3.5. Let's plot in over here. This is my undefined, and this is going to be 1, negative 3, That's my new point. And then I have negative 3.5. 2.5 over here. So this is going to be my new graph. It doesn't look that nice though. And the other point will be over here. Negative 1, negative 5. Let's talk about the last one. I'm not gonna give all the, I'm not gonna work on all the details over here. So on this one, for the vertical asymptote, what do? We said x minus 3 equal to 0. So what will be the vertical asymptote? X equal to 3. And horizontal asymptote? Y equal to 1. Domain. Negative infinity up to 3, union 3 to infinity, and range. Negative infinity up to 1 and 1 to infinity. Let's draw the asymptotes first. X equal to 3. That's my first asymptote. And the other one, y equal to 1. And the graphs are going to be, the first point is over here, the second point, the other side is going to be over here. I'm not making the table, but whenever you are trying to make the table over here, you have to, for the original one, I'm just showing what's the transformation. For the vertical asymptote, since you are going to the right, x minus 3, so you are going to add 3 over here, and you're going to add 1 over here. That's going to give you the new points. I'm not making it. I want to show you one more problem, that's it. If you are given a table or you are given a graph, we can ask you to find the vertical asymptote and the horizontal asymptote domain range from this one. So if the table is given, it's very easy because you can see this is undefined. Since this is undefined, that's going to be my that's going to be the vertical asymptote. So we can write it down already. My vertical asymptote is going to be x equal to 0. Now we have to, the vertical asymptote and the domain is going to be same. What will be the domain now? Negative infinity up to 0 and then 0 to infinity. Now the horizontal asymptote. Whenever you are, please pay attention to the board. Whatever you are doing, that needs to stop for a sec. And look at the board, please. For the horizontal asymptote, we have to take the point, the top one and the bottom one, from the, whichever is giving you the undefined value. And we're going to take the y values from here, and we are going to add them. So negative 1.25 plus negative 0.75 divided by 2. See what you get? What's the value? What is the value? Huh? You're going to take both of them, add them, divide it with the 2. What's the value? 1? Okay. Not negative 1, it's a positive 1. So your horizontal asymptote is going to be y equal to 1. We need to write the equation also. We need to know how to write the equation. And the equation will be y equal to 1 over x minus 1.
It's supposed to be negative.
This is negative 1?
Yeah. You're dividing negative 2 by 2.
Yes, negative 1. Thank you. What will be the range now? Negative infinity up to negative 1 and negative 1 up to a positive infinity. Let's look at the graph. Graph is easier because you can see it. So if I look at this one, no one is going through this line. Nobody is going through this line either. Perfect. Tell me the vertical and the horizontal asymptote. Y equals 1. That's for the horizontal. And vertical? X equals 5. So that gives me the domain and range. Do the last two problems. I'm giving you 3 minutes. I'm going a little over the time, but I really need to check both of these problems. All right, so for this one, the vertical is going to be x equal to 0, x equal to 4. That gives me the domain. Now for this one, this is undefined, so that's going to be x equal to negative 5. And the horizontal asymptote, x equal to negative 6, because negative 7 plus negative 5 over 2, it's going to give you a negative 6. Now the domain, negative infinity up to a negative 5, negative 5 to infinity, and negative infinity up to negative 6, and negative 6 to infinity. Now pay attention to this one. In most of the times, we are going to ask you for the equation. So whenever you are trying to find the equation from this one, try to look at the difference between them. Over here, the vertical asymptote was 0. So there was no shift vertically, right? So we're not moving up or down, right or left, anything. But, we're not moving left or right over here. But on this one, the vertical asymptote is negative 5. So it means that there is a shift in the left and right. So if I'm trying to write the equation over here, be very mindful on this one. It's going to be y is equal to 1 over, since I have a shift, horizontal shift. How can I write this one? How do I write the horizontal shift? X plus 5. And what will be over here? Minus 6. That's going to be your equation. That's what I wanted to mention. This is a very unique thing that happens whenever you are dealing with this ones. Now let's look at the homework, please. Go to your homework packet. You're going to flip it and you're going to do left and right, just the first page, this whole thing. And it's due tomorrow. Any questions? We good? Great.